The morning of November 8, 1942, broke cold and grey over the Atlantic coastline of Morocco, bringing with it a dawn that would expose a catastrophic failure in American military preparation. On the damp sands of Fedala Beach, thousands of American soldiers, many of whom were barely removed from civilian life, found themselves crouching behind dunes and shallow berms as the ominous silhouette of French Renault tanks, operating under the Vichy government, ground slowly toward them. These men were armed with a weapon that had been touted as a revolutionary equalizer, a device that was supposed to render the terrifying machinery of armored warfare obsolete in the face of the common infantryman. It was a metal tube, roughly 4.5 feet in length, which they had been issued only the night before. Most of the men holding these tubes had received no instruction, no manual, and no practice. They had simply been handed the weapon, along with a handful of rocket-propelled grenades, and told that this device, whimsically nicknamed the Bazooka, would stop a tank as the enemy armor closed the distance, tracks churning the wet sand and turrets traversing to hunt for targets. The soldiers shouldered the unfamiliar weight, peered through crude iron sights, and squeezed the triggers. In instance after instance, across the chaotic landing zones of Operation Torch, the result was a terrifying silence. The rockets did not fire. The soldiers pulled the triggers again, harder, with the desperation of men staring death in the face. But the weapons remained inert. The tanks rolled on, their machine guns cutting through the morning air, while American infantrymen were left holding useless metal tubes that had become nothing more than dead weight in a killing zone. To understand how the United States Army arrived at this disastrous moment, one must look back nearly a quarter of a century to the end of the previous global conflict. The origins of the bazooka were rooted in the visionary work of physicist Robert Goddard, who had demonstrated a tube-launched rocket to the Army Signal Corps at the Aberdeen Proving Ground in Maryland as early as November 1918. Goddard's demonstration was successful, proving the viability of a recoil-free launcher that could be operated by a single soldier. However, history is often shaped by timing, and Goddard's timing was unfortunate. His demonstration took place a mere 5 days before the armistice that ended World War I with peace declared. The military's appetite for funding experimental weaponry evaporated almost overnight. The concept of a man-portable rocket launcher was filed away in the dusty archives of bureaucracy, ignored and forgotten as the United States retreated into isolationism. For 2 decades, while the world slowly drifted toward another cataclysm, American infantry doctrine remained stagnant. Relying on the Baltican rifles and machine guns that had defined the trench warfare of 1918, the tank was viewed by many in the American military establishment as a clumsy, mechanical curiosity, prone to breakdowns and slow movement, hardly a threat that required a dedicated infantry countermeasure. This complacency was shattered. In September 1939, when the German Wehrmacht unleashed the Blitzkrieg upon Poland, the world watched in horror as panzer divisions sliced through traditional defensive lines, encircling and annihilating infantry formations with a speed and violence that rendered established military tactics obsolete. The lesson was repeated with even greater brutality in the spring of 1940 as German armor rolled through France, crushing the French army and driving the British Expeditionary Force into the sea at Dunkirk. By the time the United States began to mobilize in earnest, the reality of modern warfare was undeniable. The tank was king, and the American infantryman was woefully unprepared to face it. The standard American anti-tank weapon of the time was the 37mm towed gun, a piece of artillery that was heavy, difficult to maneuver, and required a crew to operate. Against the evolving armor thickness of German tanks, the 37mm was rapidly becoming a door-knocker, capable of alerting the enemy, but rarely destroying him. The only other option available to the infantry was the anti-tank grenade, a suicide weapon that required a soldier to sprint within 30 yards of a tank effectively inside the kill zone of its machine guns to deliver a shaped charge by hand. The situation was desperate. The Army needed a miracle, and they needed it immediately. Enter Major Leslie Skinner of the Army Ordnance Corps and his brilliant young assistant, Lieutenant Edward Uhl. Skinner had been tinkering with rocket concepts for years, convinced that they held the key to delivering a heavy warhead without the punishing recoil of a conventional gun. The problem was the delivery system. The Army's most effective anti-tank munition was the M10-shaped charge grenade, a 4-pound explosive capable of burning through nearly 4 inches of steel. However, the M10 was too heavy to be fired from a rifle grenade launcher, and no soldier could throw it far enough to be safe or effective. The challenge was to marry the hitting power of the M10 with a rocket motor that could propel it accurately over hundreds of yards. Uhl, a fresh engineering graduate from Lehigh University, threw himself into the problem problem in early 1942. He experimented with various designs, but every concept hit a snag, protecting the shooter from the rocket's scorching exhaust. The solution, when it came, was a moment of serendipity that would change the course of the war. While walking past a scrap pile at the Aberdeen Proving Ground, UL spotted a discarded steel tube. It was roughly 5 feet long and happened to be 60 millimeters in diameter, the exact size of the M10 grenade. A light bulb went on in All's mind. If the rocket were fired from inside the tube, the steel would contain the exhaust and vent it safely out the back, away from the operator. He grabbed the scrap metal, rushed back to the workshop, and with Skinner, fashioned a crude launcher using a wooden rifle stock and a simple electrical ignition system. The prototype was ugly, cobbled together from junk and spare parts, but it worked. During the first test firing into the Potomac River, the rocket flew straight, and the operator remained unburned. The true test came in May 1942, during a competitive trial against other anti-tank concepts like spigot mortar and recoilless rifles. In their haste to prepare for the demonstration, Skinner and UL realized they had forgotten to attach sights to the launcher. In a display of quintessential American ingenuity, Skinner bent a wire coat hanger into a crude loop and soldered it to the tube minutes before the trial began. Despite the improvised sight, the tube launcher was the only weapon that consistently hit the moving tank target. General Gladian Barnes, head of Ordnance Research and Development, was so impressed that he personally fired the weapon, hitting the target on his first attempt. The order for 5,000 units was issued immediately. The weapon was officially designated the M1 rocket launcher, but the troops, noting its resemblance to a crude musical instrument played by radio comedian Bob Burns, universally christened it the Bazooka. The rush to production, however, sowed the seeds of the disaster that would unfold on the beaches of North Africa. General Electric was given 30 days to manufacture the first batch of launchers. In the frantic push to meet this impossible deadline, critical quality control measures were bypassed. Under normal peacetime standards, each launcher tube would have been checked with precision bore gauges to ensure a perfect internal diameter, but there were no bore gauges available, and no time to make them. As a result, tubes left the factory with slight variations. A tube that was too tight would cause the rocket to stick. One that was too loose would allow gas to escape, reducing range. Furthermore, due to wartime material shortages, the steel used for the tubes was often of lower quality than specified. This substandard metal, when heated by the desert sun or rapid firing, could weaken, leading to catastrophic ruptures that would maim the soldier pulling the trigger. The ignition system was equally flawed. It relied on dry cell batteries housed in the wooden stock to send an electric current to the rocket. These batteries were highly sensitive to temperature and humidity. In the cold, they lost power. In the heat, they leaked. The salt air of an ocean voyage corroded the electrical contacts, creating an invisible barrier of oxidation that would break the circuit. When the bazookas were loaded onto the transport ships bound for Operation Torch, they were essentially prototypes pressed into service. The final, and perhaps most unforgivable, error was a failure of communication. The weapons were crated and shipped without adequate manuals or training programs. The secrecy surrounding the new weapon was so tight that the officers leading the invasion were unaware of its existence until the crates were opened. General Eisenhower himself was horrified to learn, mere hours before the invasion, that his troops had no idea how to use the anti-tank weapons they were carrying. The result was the chaos at Fedala. Soldiers, under fire and terrified, fumbled with the unknown devices. They loaded rockets incorrectly, failed to clean corroded contacts, and trusted in batteries that had long since died. The few rockets that did launch often bounced off the enemy tanks because the pointed nose of the M6 warhead tended to deflect upon impact rather than detonating. It was a debacle. The bazooka, intended to be a savior, became a liability. Soldiers threw them into the sand, opting to face tanks with rifles rather than trust a weapon that refused to fire. The failure in North Africa was not just a mechanical breakdown, it was a psychological blow to the infantry. Trust in equipment is the bedrock of morale, and the bazooka had shattered that trust. Reports flooded back to the Ordnance Department, describing the weapon as useless and dangerous to the operator. But the war did not pause for redesigns. In early 1943, at the Battle of Kasserine Pass in Tunisia, American forces faced the seasoned veterans of the German Afrika Korps. Here, the bazooka's failures were magnified against the heavy armor of German Tiger tanks. The M6 rockets, even when they did fire, lacked the penetration power to defeat the thick frontal armor of the Tigers. American soldiers watched in dismay as their warheads exploded harmlessly against the German steel, leaving only scorch marks while the tanks returned fire with devastating 88mm cannons. The defeat at Kasserine was total, a humiliation that cost thousands thousands of American lives. In the retreat, vast quantities of equipment were left behind, including crates of pristine, unopened bazookas. It was at this juncture that the story of the bazooka took a deeply ironic turn. The captured weapons were shipped back to Germany for analysis. German engineers, far from mocking the failed American design, recognized the brilliance of the underlying concept. They saw that the Americans had solved the portability problem, but had failed in the execution. With characteristic efficiency, the Germans set about reverse engineering the bazooka, but they scaled it up. They realized that a 60mm warhead was too small for modern armor, so they increased the caliber to 88mm, nearly doubling the penetrating power. They abandoned the troublesome battery ignition system in favor of a robust magneto-generator, spring-loaded device that created its own spark when the trigger was pulled, impervious to weather or battery life. They added a blast shield to protect the operator from the larger rocket motor. The result was the Raketen Panzerschreck, or tank terror. By late 1943, American troops in Italy began to face this terrifying new weapon. The irony was bitter. American soldiers were being killed by a superior version of their own invention, a weapon that worked every time the trigger was pulled. Unlike the faulty tubes they carried. Back in the United States, the Ordnance Department was in crisis mode. The reports from the front could not be ignored. Production of the M1 was halted, and a crash program was initiated to fix the flaws. The result was the M1A1 and subsequently the M9 launcher. The engineers addressed every failure point. The battery system, the Achilles heel of the original design, was scrapped in favor of a magneto ignition, similar to the German improvement. The rocket was redesigned with a blunted nose, the M6A1 and later M6A3, to prevent ricochets on sloped armor. The tube was reinforced with wire wrapping to prevent ruptures, and the length was increased to improve accuracy and ensure the rocket motor burned out before leaving the barrel, protecting the soldier from burns. The bore tolerances were strictly enforced, and the steel quality was standardized. The redemption of the bazooka began in the olive groves of Sicily and the rugged hills of Italy. During Operation Husky in July 1943, paratroopers of the 82nd Airborne Division, led by Colonel James Gavin, found themselves isolated and facing a counterattack by the Hermann Panzer Division. Armed with the improved M1A1 launchers, they engaged the German Tiger tanks at Biazza Ridge. While the rockets still struggled to penetrate the thickest frontal armor of the Tigers, they fired reliably. The paratroopers learned to aim for the tracks, the vision slits, and the engine compartments. They immobilized the giants, stripping away their infantry support and forcing the tanks to withdraw. It was a turning point. The weapon was not a magic wand that vaporized tanks, but it was a fighting tool that gave the infantry a fighting chance. As the war moved into the hedgerows of Normandy and the urban ruins of Germany, the M9 bazooka became a ubiquitous and essential tool. Soldiers learned its limitations and maximized its strengths. They stopped trying to go toe-to-toe with King Tigers from the front, and instead set up ambushes to hit the thinner side and rear armor. But the bazooka found a second life as a bunker buster. In the close quarters fighting of French villages and German towns, the bazooka was used to blast holes in walls, clear snipers from church steeples, and silence machine gun nests. It became the infantryman's pocket artillery, a versatile sledgehammer that could solve a variety of tactical problems. In the Pacific theater, the battle against the elements was as fierce as the battle against the Japanese. The extreme humidity and salt spray of the jungle islands wreaked havoc on the early battery-operated Marines on Guadalcanal and Tarawa cursed the weapons as contacts corroded overnight and rockets fizzled in the damp air. It was only with the arrival of the magneto-equipped M9 that the bazooka truly proved its worth against the Japanese. The Japanese tanks were lighter and more vulnerable than their German counterparts, making them easy prey for the bazooka. However, the true value of the weapon in the Pacific was against fortifications. On Iwo Jima and Okinawa, the Japanese had constructed elaborate networks of caves and concrete bunkers that were impervious to offshore naval bombardment. The bazooka became the key to unlocking these defenses. Marines used them to fire shaped charges directly into the firing slits of bunkers, neutralizing the occupants with concussive force and shrapnelware. Flamethrowers and satchel charges could not reach. By the end of the war, the bazooka had evolved from a national embarrassment into an icon of American military power. It had been produced in numbers exceeding 400,000. It had spawned a new class of weaponry that would dominate the remainder of the 20th century. But the legacy of the bazooka is also a cautionary tale. It is a stark reminder of the cost of unpreparedness. The blood spilled on the beaches of Morocco and the passes of Tunisia was the price paid for a military establishment that had allowed itself to fall behind, and an an industrial complex that prioritized speed over quality. The eventual success of the M9 and the later M20 Super Bazooka, which finally adopted the larger caliber necessary to kill heavy tanks, was a triumph of engineering adaptation. But it was a triumph built on the hard lessons of failure. The young soldiers who stood their ground at Kasserine with weapons that would not fire deserve to be remembered not just as victims of a faulty system, but as the catalysts for the improvements that eventually helped win the war. Their experience forced the United States Army to confront its deficiencies and innovate under fire, turning a scrap pile experiment into one of the most significant military inventions of the modern era.